Problem 1. Let probability of x equals to k equal to bkp to the k minus 1 power. K is 1 to the infinite. P greater than 0 and less than 1. Question A. Find B so that probability of x equals to k represents a probability mass function. If probability of x equals to k is a probability mass function, the sum of k equals to 1 to infinite probability of x equals to k should be 1. So sum k equals to 1 to infinite bkp to the k minus 1 power equals to 1. So b equals to 1 over sum k equals to 1 to infinite. To figure out this, we can calculate sum k equals to 0 to the infinite p to the kth power. This is equals to 1 over 1 minus p. And we can differentiating both sides. D over dp sum k equals to 0 to the infinite p to the kth power equals to d over dp 1 over 1 minus p equals to 1 over 1 minus p squared. D over dp sum k equals to 0 to the infinite p to the kth power equals to sum of k equals to 1 to the infinite k p k to the k minus 1 power, which is equals to 1 over 1 minus p squared. So b equals to 1 minus p squared. Question B. Find the expectation of x. Expectation of x equals to sum k equals to 1 to the infinite k times b k p to the k minus 1 power equals to b times sum k equals to 1 to the infinite k squared times p to the k minus 1 power. To find this, we can calculate k equals to 1 to the infinite k times p to the kth power first. This equals to sum k equals to 1 to the infinite k times p to the k minus 1 power times p, which is equals to 1 over 1 minus p squared times p. And then we can differentiate in both sides. D over dp sum k equals to 1 to the infinite k times p to the kth power equals to d over dp times p over 1 minus p squared. D over dp sum k equals to 1 to the infinite k times p to the kth power equals to sum k equals to 1 to the infinite k squared times p to the k minus 1 power. And d over dp times p over 1 minus p squared equals to p plus 1 over 1 minus p cubed. Then we can get sum k equals to 1 to the infinite k squared times p to the k minus 1 equals to p plus 1 over 1 minus p cubed. So the expectation of x equals to b times p plus 1 over 1 minus p cubed equals to 1 minus p squared times p plus 1 over 1 minus p cubed equals to p plus 1 over 1 minus p. Question C. Find the expectation of x squared. Expectation of x squared equals to sum k equals to 1 to the infinite k squared times b k p to the k minus 1 equals to b times sum k equals 1 to the infinite k cubed times p to the k minus 1. We can use same way as question B. Sum k equals to 1 to the infinite k squared times p to the k equals to sum k equals to 1 to the infinite k squared times p to the k minus 1 times p equals to p plus 1 over 1 minus p cubed times p equals to p squared plus p over 1 minus p cubed. And we can differentiate in both sides. D dp sum k equals to 1 to the infinite k squared times p to the k equals to d over dp times p squared plus p over 1 minus p cubed. D over dp sum k equals to 1 to the infinite k squared times p to the k equals to sum k equals to 1 to the infinite k cubed times p to the k minus 1, and p squared plus p over 1 minus p cubed equals to p squared plus 4p plus 1 over 1 minus p to the fourth. So sum k equals to 1 to the infinite k cubed times p to the k minus 1 equals to p squared plus 4p plus 1 over 1 minus p to the fourth. So expectation of x squared equals to 1 minus p squared times p squared plus 4p plus 1 over 1 minus p to the fourth equals to p squared plus 4p plus 1 over 1 minus p squared. Question D. Find the expectation of x squared minus square of expectation of x. We already got expectation of x and the expectation of x squared. So it's equal to p squared plus 4p plus 1 over 1 minus p squared minus square of p plus 1 over 1 minus p is equals to p squared plus 4p plus 1 minus p squared minus 2p minus 1 over 1 minus p squared equals to 2p over square of 1 minus p. So when p equals to 1/3, probability of x equals to k equals 1 minus 1/3 square times k times p to the k minus 1 equals to 4 over 9 k p to the k minus 1. Probability of x equals to k given x greater than or equal to 2 and less than or equal to 5 equals probability of x equals to k and x greater than or equal to 2 less than or equal to 5 over probability of x greater than or equal to 2 and less than or equal to 5 equals to this over sum k equals to 2 to 5. Probability of x equals to k. So sum k from 2 to 5, probability of x equals to k is 4 over 9 times 2 times 1 over 3 plus 3 times 1 over 3 squared plus 4 times 1 over 3 cubed plus 5 times 1 over 3 fourths equals to 0.538. So this equals to probability of x equals to k times 1 over 0.538 equals to 1 over 0.538 times 4 over 9 times k times 1 over 3 to the k minus 1. For k greater than or equals to 2 and less than or equals to 5.